Hello, Dr. Phelan and audience members. My name is William, and I am joined by my group mates Chester, Alexandria, Tyler, and Zachary to present our Canal Cleanup Energy Efficiency Project for MAE 494. Now, the basis of this project was rooted in our capstone, where our group designed and built a canal cleaning conveyor system intended for use in the SRP canals. The project came about because many of the Arizona canals struggle with litter and can have large amounts of trash buildup depending on the location and time of year. The surface level trash is unsightly and poses a potential environmental hazard to both the local wildlife and the people who live near the canals. And while they do periodically perform manual cleanings of the canal systems, keeping up with the litter as it accumulates is a difficult process that would be greatly aided by a semi-automated system. The device that we built acts as a conveyor, which effectively skims the surface of the canal and removes surface level trash. While the prototype that our group built was effective, the original system is unfortunately not very energy efficient, and the excessive power consumption makes the device not feasible for large-scale use. As such, this project aims to evaluate realistic and cost-effective ways to significantly increase the energy efficiency of our original capstone to make scaling the system much more feasible.
Currently, the canal systems in Arizona are manually cleaned by SRP. This process is done by draining the canals and removing any soot and man-made debris that is left behind. This entire process can take upwards of 10 years to fully clean the canal systems in the larger Phoenix area. During this time, the canal banks are closed to the public and the use of large machinery can cause major disturbances to the surrounding housing. An existing solution that inspired us is the Ocean Cleanup Project. This organization has a similar goal of cleaning the world's oceans and rivers of floating trash. Unfortunately, they exist on a much larger scale, which leaves nothing that can help clean smaller canals like the ones in our surrounding area. Our design is reminiscent of the Ocean Cleanup Interceptor on the right and will be discussed in more detail in the coming slides.
The canal cleaner seen here has been developed to remove trash from the Arizona canals using a conveying system inspired by the Interceptor. The canal cleaner is a portable device which can be used in multiple canals to remove debris from above and below the water surface. This portable conveying system is currently ran by a 3/4 horsepower motor, which is powered by the grid under an SRP general purpose power plant. We have developed three options to minimize the energy consumption of this machine and therefore its carbon impact. Option one is to install a 1/4 horsepower premium efficiency motor in replacement of the 3/4 horsepower motor used. Option two is to install solar to reduce or even eliminate the need for grid power. Finally, option three is a hybrid between the two previous options, which will utilize both solar and 1/4 horsepower premium efficiency motor to reduce the energy consumption of this machine.
In order to replace the old motor, which is a 3/4 horsepower motor, with a more efficient one, we first calculated whether a 1/4 horsepower would be enough in order to save money and still increase efficiency. The load from the trash was taken into consideration, and we found that a 1/4 horsepower motor would be sufficient to run the canal cleaner. Based on the previous calculations, the proposed motor will be a 1/4 horsepower motor with an efficiency of 74%. For the cost savings calculations, we decided to go with a 12-hour runtime and assumed it would be off of SRP's general service price plan. The energy use for the current motor was found to be 4,225.2 kilowatt hours per year, while the energy use for the higher efficiency motor was found to be 827.9 kilowatt hours per year. That means by replacing the old motor with the higher efficiency motor, there would be an energy cost savings of $273.48 per year, and the simple payback is 2.108.
Option 2 utilizes solar panel integration for energy efficiency. There are some initial assumptions made, including consistent operating hours, no energy loss due to the motor, and DC to AC converter already in our possession. We did the calculations for 50, 110, 400, and 800 watt solar panel systems. The respective prices are listed next to them. This left the paybacks at 3.4 years, 7.15 years, 3.74 years, and 4.64 years. The figure on the right shows how solar panel wattage affects the paybacks of each system. The last option we decided to go with was the high efficiency motor combined with the best payback solar panel option. The total upfront cost for this would be $816.24. The estimated energy savings came out to 4,273 kilowatt hours per year, leaving an energy savings cost of $344 per year. This would have a payback of 2.37 years. To summarize our project, we initially came up with our capstone with the intentions of removing harmful waste of the Phoenix canals. For the conveyor system for the canal, we used a 3/4 horsepower motor that had an efficiency of 43.5% due to budget constraints. The proposed solution were the premium efficiency motor, the solar panel utilization system, and lastly, the motor and solar power combination system. These each had respective paybacks of 2.108 years, 3.4 years, and 2.37 years. The best solution was a combination solution, as there are very little differences between the payback from this and the high efficiency motor, and this allows the conveyor to have power off of the grid and reduce costs further down the line. Here are our references.